Okay, so in the exponential notes, I said we're going to do some of these in class, but I want to talk about them in this video since we're getting a week late start here. So I'm going to do some underpinnings of how you can do exponential functions without the graph. So first I'm just going to go over some concepts you need to know, then we're going to apply them to do this. So again, these are for exponential functions, and in the previous video for exponential functions, I talked about just looking at the graph. So a graph of an exponential function could look like this or something like that. I'll do another one maybe like this, and then a third one like this. All right, so all of these are exponential functions, and we're talking about getting the limit from the equation. So like you might see something like this, right? So we want to find the limit just looking at the equation and not the graph. So that's what we're going for here. What I've told you previously is, well, think about the graph and then figure out the limit from there. One note I'm going to make here is that we're talking about x approaching infinity or x approaching negative infinity. Those are the interesting points. Anywhere else, if I try to find the limit of an exponential as x approaches 4, or any other finite number, it's not that interesting because, as you can see, all these exponential graphs are continuous. And if a function is continuous, well, then the limit of that function is just equal to the function value. So in other words, if I wanted to find the limit as x approaches 4 of 2 to the x, which is an exponential, I'll just plug in the 4 and the answer will be 2 to the 4th. So this is the part where that's equal to f of 4. You just plug in the number and it'll work because the function's continuous. So the interesting ones are at infinity and negative infinity. And please keep in mind that as x approaches infinity, they're talking about what y value are we approaching all the way to the right. And then as x approaches negative infinity, what y value are we approaching all the way to the left? So on this graph, the answer here would be the limit as x approaches infinity of this function, which is exponential, would be 0. On this side, the limit as x approaches negative infinity, because we're going all the way left of this function, would be negative infinity because it goes down forever. This one here would be infinity. As x approaches infinity, the limit would be infinity. So as we go all the way to the right, the function goes up to infinity. So the limit would be infinity. And over here on the left side, that would be the limit as x approaches negative infinity of this function would be 0. This function here, the limit as x approaches infinity would be 5, and the limit as x approaches negative infinity, whoops, gotta put that function in there, would be negative infinity because it goes down forever. So remember, this right here is the y value that we're approaching, so we would go down to negative infinity. This is the y value we're approaching as we go all the way to the right, which means we'd be approaching that asymptote. Okay, and same for all of these. So the question is going to be, can we find these limits of exponentials without thinking about the graph? And the answer is yes. Here are some underpinnings that you need to know. An exponential function will be some number raised to the variable x. So like they're usually of the form a times b to x. So some examples would be y equals negative 2 times 3 to the x, y equals 4 times 1/3 to the x, y equals negative 4 to the x. Now here I want you to think of this one as negative 1 times 4 to the x, because one important thing about an exponential is the base cannot be negative. And the base can also not be 1. This is not an exponential function because 1 to the x will just make a linear function. We'll talk about that in a minute. All right, so the key to figuring these out without thinking about the graphs is thinking about what will this number approach as x goes to infinity. What will the base with the exponent approach? So in these cases, you have to consider the type of number we're looking at. So it all comes down to, is the base larger than 1 or is the base less than 1? Remember, if the base is equal to 1, we're not going to have an exponential, and the base can't be negative. So let's take a look at some of these examples. 3 to the x. What does that mean if x were infinity? It would mean 3 times 3 times 3 times 3 forever. That number would not approach anything. That number would approach infinity. How about we looked at 4 to the x? 4 times 4 times 4 times 4 times 4 forever. That would also approach infinity. What's more interesting is to look at like the other ones, like maybe 1/3 to the infinity, right? 1/3, I should put this in parentheses. 1/3 to the infinity means 1/3 times 1/3 times 1/3 times 1/3 forever, right? And that would approach 0 because the number would get smaller and smaller and smaller. If you think about that, right? The top would be 1 and the bottom would just be 3 times 3 times 3 times 3 times 3 forever. So whenever the bottom is growing faster than the top, that's going to approach 0, that number. Okay? So we're going to apply that situation here to do some of these that we skipped. So right here, I'm going to plug in infinity in for x. So think of this as 2 to the negative, I'm going to plug in infinity for x minus 2 plus 3. So we're going to start simplifying. So negative times infinity would be negative infinity minus 2 plus 3. Now I'm going to do the negative infinity minus 2. Well, that's still just going to be negative infinity because if you subtract 2, it doesn't do much to infinity. It just keeps it as negative infinity. Now, when we're analyzing these numbers back up here, notice that I always use the positive infinity here for these. Whoops, that should have been an infinity plugged in. You can, but it's harder to analyze when it's negative infinity. So we want to make this a positive infinity. So there's a rule of exponents that said, if you switch the sign of the exponent, you must take the reciprocal of the base. So now I can analyze this number. 1/2 to the infinity means 1/2 times 1/2 times 1/2 forever. And since the bottom is growing faster than the top, that's going to approach 0. So this part in the circle becomes 0, and then 0 plus 3 equals 3. So that's how I would do this limit. I would take the infinity, plug it in for x, and then do a numerical analysis like this. And the whole key is you want to get it down to a number to the positive infinity, and then decide, does that number go to 0 or does that number go to infinity? 2 to the negative x. So let's take a look at this function. 2. Where's the exponent? Yep. To the, I got to put it in parentheses, negative x minus 2. And then there was a plus 3. So if you look at that graph, as x goes to infinity, the number we're approaching is 3. So watch. See that y value? Right? As we move the x closer to infinity, look at that y value. It's getting closer and closer to 3. Desmos just thinks it's 3 because it's close enough. Because it starts doing round off error. But if I zoom in, you can see it never quite gets there. And when it looks like it does, you can just zoom in further, right? So that's how you would do that one. Let's look at this one here. So if I plug in negative infinity, I have negative 1/4 to the negative infinity minus 2. I always like parentheses here when I'm substituting in for x. So the negative times the negative becomes a positive infinity minus 2. And now I think of this negative out front as a negative 1. I'll deal with that later. Infinity minus 2, I'm going to deal with that now. That's still infinity. Subtracting 2 off infinity doesn't do much. Now I'm going to analyze this number. What's 1/4 to the infinity? Well, just like before, since 1/4 is less than 1, you have this situation going on here. 1/4 times 1/4 over and over goes to 0. So now I would have negative 1 times 0, because this part all goes to 0, plus 3. So negative 1 times 0 is 0, plus 3 is 3. So that answer is 3. I'm not going to show you the graph. You can check that out on your own. All right, let's look at this one. If I plug in negative 2, well, oh, that's one of those trivial ones. Remember I said the only ones that are interesting are the ones that go to infinity and negative infinity. Those are the ones we got to kind of figure out. If we're just at negative 2, just remember this is some exponential function. I don't know, maybe it looks like this. And I'm just finding what's the y value at, let's try that again. What's the y value at negative 2? That's all we're doing here. So f of negative 2, I'd plug it in and get 1/2. Sorry guys, my eraser. Here we go. 1/2 negative 2 plus 2. I just plugged in negative 2 for x. This part is 0, so I get 1 half to the 0 minus 1. Anything to the 0 power is 1, and 1 minus 1 equals 0. So this one, the answer would have been 0. Okay? So that would have been the y value that we're approaching as x approaches negative 2. This one here, another trivial one. I plug in negative 1 and I get 2 to the negative 1 minus 2 plus 2. So I get 2 to the 1 minus 2 plus 2. 2 to the negative 1 plus 2. I get 2 to the negative 1 is actually 1 half plus 2. So I would get, what, 5 halves, I think? All right. That's how you can do these quickly without having to think about the graph. I like this way better, so I wanted to make sure I show that to you.